welcome back to the channel. My name is Dave. In today's video, I'm going to be going over the rest of the questions from the Oxford University Mathematics Admissions Test for 2021. One thing I didn't mention in the previous video is that actually all of the questions in both this video and the last video are in fact multiple choice. You do get a little bit of help, but I think it's important to be able to calculate the answer when necessary. That being said, let's get to work and look at the questions. We are given a function which is log base 2 of the quantity 9 minus sine x minus 6 times cosine squared of x, and we're asked which of the following graphs or sketches of graphs on the range 0 is less than x is less than 360 degrees best suits this equation. Now, one way of doing this would be to take a look at the thing inside the parentheses, and it's trivial to show that 9 minus 8 times sine of 90 degrees minus 6 times cosine squared of 90 degrees is equal to 1. And since the log of 1 in any base is equal to 0, we can sort of eyeball the answer and think that A is the correct answer, because it has a 0 about 1/4 of the way between 0 and 360. However, we can also prove this by using the first derivative of the function, which we will do now. We'll be using the identity sine squared theta plus cosine squared theta equals 1 more time. And by replacing cosine squared x with 1 minus sine squared x, we come to the expression y equals log base 2 of 3 minus 8 sine x plus 6 sine squared x. Now we have to let sine x equal t, and we'll get y equals log base 2 of 3 minus 8t plus 6t squared. We can see that the function 3 minus 8t plus 6t squared will attain a local minimum at minus 8 plus 12t equals 0, or when t equals 2/3. Since sine of x is equal to t, which is equal to 2/3, this gives a value of x equals the inverse sine of 2/3. And once again, we don't have access to a calculator, so we don't know the exact value of the inverse sine of 2/3. So for now, we'll just call it theta. We do know that it has to have some value between 0 and 90 degrees. And since we also know that sine of theta is equal to sine of 180 minus theta, we expect there to be two minima between 0 degrees and 180 degrees. So once again, we can take a look at the two choices. So since log of base 2 is 0 if and only if x is equal to 1, the answer must therefore be A. And A is our final answer. In this question, we have to find the recursive formula for a sequence as described in the question. A sequence is defined by a sub 0 is equal to 2, and then for n greater or equal to 1, a sub n is 1 more than the product of all the previous terms. We can represent the nth product of all previous terms in the following way. We write it as p sub n, meaning the nth product, is equal to a sub n times p sub n minus 1. We also use the information that it is 1 greater than the product of all the previous terms, and we write down a sub n is equal to p sub n minus 1 plus 1, which implies that p sub n minus 1 is equal to a sub n minus 1. By replacing this in the original formula, we have p sub n is equal to a sub n times the quantity a sub n minus 1. However, we also know that p sub n is equal to a sub n plus 1 minus 1. All we did to get this is we shifted the indices of the n's by 1. Therefore, we can say that a sub n plus 1 minus 1 is equal to a sub n times the quantity a sub n minus 1. And therefore, we can say that a sub n minus 1 is equal to a sub n minus 1 times a sub n minus 1. Again, all we did was we reduced the indices by 1. When we move the negative 1 over to the right-hand side, we will find that B is the correct answer. In this question, we're given 4 points, A, B, B, C, C, D, and D, A, and we're asked to tell under what conditions ABCD has all 4 sides the same length. We can use the distance formula to determine the lengths of each of the sides, and we can make these equal to each other. Hence, we are going to have the square root of the quantity a minus b squared plus b minus c squared is equal to the square root of the quantity b minus c squared plus the quantity c minus d squared. We will also have the square root of the quantity b minus c squared plus the quantity c minus d squared is equal to the square root of the quantity c minus d squared plus the quantity a minus d squared. If we square both sides, we can eliminate the square roots, and after some simplification, we arrive at the quantity of a minus b squared is equal to the quantity of c minus d squared. And we also have the quantity b minus c squared is equal to the quantity a minus d squared. Since this is a multiple choice test, if we look at the choices, A and C can be eliminated directly because they can't both be right. And also B can be eliminated. This would be the result if we compared the opposite sides rather than the sides that are adjacent. So we're left with choices D and E. A minus B squared minus the quantity C minus D squared is equal to 0. This is clearly the difference of 2 squares, and factoring this expression gives us the quantity a minus b plus c minus d times the quantity a minus b minus c plus d is equal to 0. And we can see that this matches with answer choice D. Hence, we would say that D is the correct answer. So this would conclude the multiple choice section of the Oxford Mathematics admissions test. Following this, there would be a number of questions where applicants would be required to write out their answers in full. And the questions that you will answer depend on the specific department that you are applying to at Oxford University. If you're interested in seeing me do some of these questions, please comment down below on what you'd like to see. And once again, if you've taken this exam or just grew up in the British education system and have taken similar exams, please feel free to comment as well. As always, thanks for watching, and don't forget to like the video and subscribe to the channel to get updates and watch future videos. I'll see you in the next video.